Digital storage units are used to measure how much data a device can store or process. Everything on your computer, files, images, videos, apps, is made up of tiny pieces of data, and these units help us understand how large that data is. They follow a structured system, starting from very small units and scaling up to massive ones used in data centers. So now, let's break down every digital storage unit clearly, from the smallest to the largest. Bit B, the smallest unit of digital storage, is the bit. A bit can only hold one of two values, 0 or 1. These binary values are the foundation of all computing. Every file, image, or video is ultimately made up of millions or billions of bits. Nibble. A nibble consists of 4 bits. It's not commonly used in everyday computing, but it's helpful in understanding how data is grouped at a low level, especially in programming and hardware design. Byte. A byte is made up of 8 bits. This is one of the most important units because it typically represents a single character, like a letter or number. For example, the letter A takes up 1 byte of storage. Kilobyte, KB. A kilobyte is roughly 1,000 bytes, or technically 1,024 bytes in binary systems. Small text files are usually measured in kilobytes. For example, a short document or a simple image might be just a few KB in size. Megabyte MB. A megabyte equals about 1,000 kilobytes. This is commonly used for slightly larger files like songs, images, or small applications. For instance, a typical MP3 song might be around 3 to 5 MB. Gigabyte. A gigabyte equals about 1,000 megabytes. This is one of the most commonly used units today. Smartphones, laptops, and USB drives often measure storage in gigabytes. A full HD movie might take up several GB. Terabyte. A terabyte equals about 1,000 gigabytes. This is used for large storage systems like hard drives and SSDs. Many modern computers now come with 1 terabyte or more of storage, which can hold thousands of movies or millions of photos. Petabyte, PB. A petabyte equals about 1,000 terabytes. This level of storage is typically used by large companies, cloud providers, and data centers. Platforms like streaming services or social media handle data in petabytes. Exabyte, EB. An exabyte equals about 1,000 petabytes. This is an extremely large unit used to measure global-scale data. For example, the total data generated on the internet in a single day can reach exabyte levels. Zettabyte, ZB. A zettabyte equals about 1,000 exabytes. This unit is used to describe massive amounts of data across the entire world. Global internet traffic and cloud storage systems are often measured in zettabytes. Yottabyte, YB. A yottabyte equals about 1,000 zettabytes. This is one of the largest standard units of digital storage. It represents an almost unimaginable amount of data, far beyond what most current systems can handle. Binary versus decimal difference. One important thing to understand is that storage units can be calculated in 2 ways: decimal, base 10, and binary, base 2. In decimal, 1 kilobyte equals 1,000 bytes, but in binary, 1 kilobyte, technically called a kilobyte or KIB, equals 1,024 bytes. This is why sometimes your storage device shows slightly less space than advertised. Bits versus bytes. Another key distinction is between bits and bytes. Storage is usually measured in bytes, KB, MB, GB, while internet speed is often measured in bits, kilobytes per second, megabytes per Gbps. Since 1 byte equals 8 bits, download speeds can sometimes appear slower than expected when converting between the two. So after seeing all these units, it's clear that digital storage follows a simple pattern. Each level is about 1,000 times larger than the previous one. From tiny bits to massive yottabytes, these units help us understand and manage the enormous amount of data we create every day. Oh yeah, I also made some other cool tech breakdown videos too, so don't forget to watch them later.